Thanks to Brilliant for supporting this episode of SciShow. Go to brilliant.org/scishow to learn more. Antarctica is famously frigid. Unlike the North Pole, which is covered in floating sea ice, Antarctica is a true continent. It's twice the size of Australia, with mountains, valleys, and other landforms, but it's almost completely covered in ice sheets that average 2 kilometers thick. But it wasn't always that way. In fact, Antarctica's current icy state wasn't exactly inevitable. It was sort of a wrong place at the wrong time sort of thing. Scientists have spent many years and many studies examining the questions of how, why, and when Antarctica froze over. For much of the continent's history, it was surprisingly lush, and lots of organisms lived there before it was cool. If you go back about 100 million years, for example, Antarctica was home to vast coniferous forests populated with all kinds of animals, including dinosaurs. This was possible because Antarctica was farther north back then, but also because the world was a warmer place. It was a greenhouse world, meaning there were no permanent polar ice caps. It wasn't until much later that our planet transitioned into a more familiar condition, an icehouse, a world with perpetually frozen North and South poles. Geologists generally agree that Antarctica's ice sheets began to form around 34 million years ago, during the transition between the Eocene and the Oligocene epochs. As for why the continent went cold, well, it's a bit complex. Antarctica was going through a lot of changes at the time. While the early Jurassic was overall warmer and wetter everywhere, Antarctica was still cooler than the other continents and was already starting to suffer from the occasional cold and dark winter. And although Antarctica was located further north than it is today, tectonic forces were gradually sliding the continent southward. But on top of that, Antarctica got lonely. No, seriously. It was around that time that Antarctica lost its last lingering connections to South America and Australia. This gave rise to one of the South Pole's most famous features, the Antarctic Circumpolar Current. This is an ocean current that surrounds Antarctica. Other ocean currents, like the Gulf Stream, carry warm and cold water to new places. But researchers believe the Antarctic Current keeps cold water flowing around Antarctica, keeping warmer water out and making sure everything stays chilly. But that's still an active area of study, and not everyone believes that's the case. Either way, it wasn't just Antarctica, the whole world was cooling down. Some scientists have referred to this time period as the Big Chill. And perhaps unsurprisingly, scientists have pinned this major climate shift on fluctuations in carbon dioxide. Ancient fossils and sediments capture chemical evidence that atmospheric and ocean compositions were changing at this time in ways that suggest CO2 levels around the world were dropping. See, those shifting continents created a bunch of mountains. Around the time Antarctica started freezing, India collided with the rest of Asia and began the uplift of the Himalayas. This created a lot of exposed rock, which is subject to chemical weathering, and chemical weathering takes up carbon from the atmosphere. It works like this. CO2 reacts with rainwater to make carbonic acid, which dissolves some of those rocks. The dissolved rock gets washed downriver to the ocean, where marine organisms like plankton use those dissolved ingredients, CO2 included, to make their shells, locking away even more CO2. In fact, plankton are a seriously potent force for climate change for multiple reasons. These tiny floating organisms leave behind a lot of fossil evidence, and geologists have observed a rise in fossilized plankton remains at the same time Antarctica was splitting off from the other continents. This leads some scientists to suspect that as the Antarctic Circumpolar Current grew stronger, there was an increase in upwelling, the movement of cold, nutrient-rich water from the deep ocean to the surface. Upwelling acts as a fertilizer for shallow waters, providing fuel for blooms of ocean plankton. And the more they grow, the more carbon dioxide they incorporate into their skeletons. When they die and sink to the ocean floor, those shells become incorporated into limestone, locking away a lot of carbon with them. And some experts say these oceanic changes weren't just in the south. As the continents shifted, ocean currents around the globe were changing. One 2015 study examined these changes by plugging these ancient conditions into the same sort of computer models that scientists use to study climate and oceans today. What they found is that changes in the flow of the Antarctic current, like the opening of the Drake Passage between Antarctica and South America, had effects on oceans around the globe. That would have led to an overall slowdown of the currents that bring deep water carbon up to the surface, keeping more of that carbon stuck underwater. Those changes and others helped global CO2 decline over the past 40 million years or so. Global temperatures dropped with it, and things started getting chilly at the South Pole. Glaciers would have started forming first in Antarctica's high mountains, then spreading to fill valleys and lowlands, the starts of ice sheets. And here's the thing about ice sheets. Once they start, they tend to get carried away. Ice has a very high albedo. That is to say, it's very reflective. Sunlight bounces off the ice and takes solar heat away with it. The more ice cover there is, the more sunlight gets reflected and the less heat sticks around. And as the ice grows thicker, it builds higher where the air is thinner and colder. So more ice forms. These are forms of positive feedback. The ice is a self-perpetuating system. More ice leads to more ice. As the millennia passed, global temperatures continued to fall, and Antarctic ice continued to grow. The Antarctic ice sheets that we all know and admire today had formed by around 14 million years ago. Antarctica had finally frozen over. But just because our southern continent is in a deep freeze doesn't mean your brain has to be. There are always more opportunities to learn new stuff, and that's why today's episode is brought to you by Brilliant.org. Brilliant has over 60 interactive courses about science, engineering, computer science, and math. They're there to help you achieve your science and math learning goals one small commitment at a time. For example, they have a brand new course on search engines that'll tell you how Google and the like can answer questions so fast, even though they have billions of websites to trawl through. It teaches computer science, and it demystifies a technology many of us use every single day. You can check out the search engines course and many more over on Brilliant. And right now, the first 200 people to sign up at brilliant.org/scishow will get 20% off an annual premium subscription. And by giving them a look, you're also helping to support SciShow. Thanks.